What is the operation going on here with this particular one? Yeah, it's multiplication. So what do I need to do then? Divide. So I have 2w equals 1 over 9, and I am dividing by 2, and I'm actually going to do this, dividing by 2. All right, dividing by 2. On the left-hand side, it cancels to a 1. On the right-hand side, what's my rule for dividing fractions? Keep, change, flip. So I keep this a 1/9. I change that to multiplication. How do I flip 2?
1 over 2.
1 over 2. And then I just multiply across. 1 times 1, 9 times 2. So for 35, this was decimals. So we are just literally subtracting decimals here. So we're going to start on this side as addition. So we're going to subtract the 0.7. Make sure you line up your decimals. On the right-hand side, it does cancel to 0, and you have just that y. And on the left-hand side, you line up your decimals and just subtract. So you are going to borrow from this 1, 12 minus 7. Make sure you bring down that decimal. 12 minus 7 is 5. 20 minus 0 is just 20. 5. In many equations, more than one operation is performed on the variable. So there is a standard order of operations, PEMDAS, which we've talked about when we're just solving with all numbers. But when you're simplifying, you're undoing it. So you're thinking a little bit out of order than what you would normally do. So normally you would do your multiplication and division first, and then your addition and subtraction, and you're actually doing the reverse here. So in this case, when you're solving equations, you're actually going to do the addition or subtraction first, and then you're going to do your multiplication division. And if you have parentheses, you actually have to simplify everything first, distribute, combine your like terms, and then add, subtract, and then multiply or divide. So you're kind of undoing that property to solve these. But your goal is to get x completely by itself that you can solve for it. So let's look at these examples that they've given us here. The rules that they have in the middle of that page is undo the addition or subtraction, then undo the multiplication or division. And by undo, they mean do the inverse. So on this example 1, we have 2x plus 6 equals 21. I want to get rid of everything that is not with my x first. So what am I going to do first here?
Subtract.
Yeah, so I have an addition of that 6. I am going to do the inverse to both sides. All right, on the left-hand side, it zeroes out, and I am left with just a 2x. I do want to bring down my equal sign. And then I just do 21 minus 6 here, which gives me 15. Now I'm going to undo the multiplication with that inverse of division. Divide both sides by 2. I get x equals 15 halves. You may leave your answer like this for me. The reason I say that is if you check this, you will want it as an improper fraction because you're about to multiply it, okay? And so I don't make you put it as a mixed number and then change it back as an improper to check it. So you can just leave it as an improper fraction. You do need to reduce. So had this been something like 15 over 21, you would have wanted to reduce, right? But 15 over 2 does not reduce, and you may leave it as an improper fraction. To check it, you will do exactly like we did with the one step. You would go back and you would say 2 times 15 over 2 plus 6 equals 21. 2 times 15 over 2 is just 15. Yes, this is a true statement. That works. All right. So you check it the same. Check it by order of operations. Parentheses, exponents, addition, multiplication, division, addition, subtraction. So when you check it, you do correct order of operations. All right. All right, example 2. You're going to treat this exactly the same. You're just going to make your rules of decimals apply here and your rules of addition and subtraction. So my first step is to get rid of this 3.6. It is subtracting, so I am going to add it. Anytime you cross the equal sign, you do the opposite. It will cancel out here. I have a over 1.5 equals, and I'm going to say negative 4.4 and a positive 3.6. Remember when I'm adding and I have different signs, I subtract and keep the sign of the larger absolute value. All right? So When I subtract decimals, I make sure they're lined up. I'm going to borrow just like I would. This is going to be a negative because my larger number is negative. I get 3 minus 3, 0. 14 minus 6 is an 8. All right. What's happening between the A and the 1.5? Division. So what do I need to do to get rid of it? All right. It will cancel to a 1 over here, and I am left with just an A. When I multiply decimals, you multiply exactly the way you would, right? I'm just going to multiply the 8 and the 5, right? It's 48 times 1, and then I'm going to add that in there. And then how many decimals do I have altogether? 2, which means my final answer needs to have 2 decimals. 1.2, and specifically positive or negative? Yep, because I have a negative times a positive. So my answer here is negative 1.2. Negative 1.2. Questions on that? Try some. All right. X over 3 minus 7. What's my first step here? My first step here is to add 7. X over 3 equals 9. Jaden, what am I going to do next? What's happening between the X and the 3? So I'm going to have to multiply both sides by 3. Yeah, so my answer here is 27. Caleb, how would I check it?
You do 27 over 3 equals 9.
So we have 9. And is that a true statement?
Yeah.
There we go. We know it's correct. All right. So this will be the same instruction really on any word problem that you get. Even when you get into science, they're going to basically tell you the same thing to do when you're trying to figure something out. The first thing you're going to do is read the problem. If you do not understand what you are looking for, you do not know how to find it, okay? Now the key here is to look for key words, all right? We've talked about keywords, product, quotient, like you're looking for things. They may use the term rectangle because if we have something like the perimeter of something, we need to know what the shape of it is. There are times when you may need to draw a picture, especially if it is like a geometric shape. While you're reading the problem, you may need to figure out what is the unknown and give it a variable. If you give it a variable, you want to label it. So don't just put X, tell me what X equals for you. If you're trying to find the number of cookies that you are baking, then X is going to equal the number of cookies, and you need to note that somewhere so that you recognize what your variable represents. The next step is to plan a method. All right, so sometimes planning involves making a table. As we get to more difficult like distance, rate, and time problems, we're going to be making some tables. Translating your words and phrases into expressions. We've done this, okay? So if they have something as this much larger than the other, or this many units bigger than the width, those are some things that you're going to have to translate into algebraic expressions and equations. Once you've set up an equation, all you have to do is solve it. Just like we've been solving these equations, you're going to create your own equation, and then you're going to solve the equation, and then you want to check your solution. By check, I don't just mean plug it back in. There's a couple things you want to go through. Did I answer the question? This is key. I have had people get through an entire problem and they never answered what I actually asked them in the first place. They solved for their variable, but their variable was not their final answer. They should have kept going after that. What did the numbers represent? So you need to interpret your answer. Does my answer make sense? Is that last question. All right. So I give the example, many, many years ago, I did a distance, rate, and time problem with a boat traveling on the water. And the person came back with an answer of over 500 miles an hour for a boat traveling on the water, right? He did not check his question as to whether or not it was reasonable. Have you ever been on a boat? If you were going 500 miles an hour, you were airborne on the boat, right? You don't go that fast, not without taking off, okay? We're talking about airplane speed, not boat speed. And so other things to look for. I've had people give me negative answers when I'm talking about time. Unless you're time traveling, we do not have negative hours, right? And so does it make sense? Did your answer make sense? That's very, very important, because if it didn't, somewhere along the way, you made a mistake. And so it's going to be a key trigger that maybe, just maybe, you did something wrong. And so you want to make sure you're answering all of these at the final. Did I answer the question? Ask, do I remember what it even represents? And now that I know what it represents, does it make sense? Does it make sense? All right? So let's look at some of these. The first one they give us is just a basic equation that we're going to interpret. 97 is 23 less than 4 times a number. All right? Find the number. So a couple keywords here that we automatically should pick up on. The word is, what did I say is always represents? Equals. Less than, this is not talking about the less than sign. This is actually talking about subtraction. And remember, when they use this form for subtraction, you're flipping the order. So we're going to interpret this. 97, we should all know how to write 97. That is my equal sign. Now, our number is 23 less than 4 times a number. Do we know that number?
No.
We do not. So we need to assign a variable. X is going to equal that number, the number that we are looking for. So if we have 4 times the number, how would we write it if I said my number is X? 4X. And how would I write 23 less than 4X?
Minus 20.
And now I have an equation. So I have looked at my problem. I am trying to solve this number. That's what I'm looking for. I have decided how to do this. I am setting up an equation to do this. So I have interpreted my words into an algebraic equation. So now I need to solve it. All right? And so I'm going to solve it the way we would solve it if this were just handed to me. What would my first step be, Hayden? What's my first step?
You negative 23.
Right, so I'm going to add the 23 to both sides. All right, it's going to cancel on this side. I'm left with just 4x. Make sure you bring down that equal sign. All right, Ryan, what do I get if I do 97 and 23?
74.
We're adding, not subtracting. Yep, so if you were subtracting, that's correct. We're going to add, though.
That's like
120, right? So 120. So 9 and 3 gives us 10. Carry it, and we're going to get 120. All right, what's my next step?
To divide 4x to both sides.
Divide the 4 from both sides. All right, what is 120 divided by 4? Go ahead.
it was
12 divided by 4 is, 3 and 0. All right. So does this make sense? How do I figure out if it makes sense? Well, 97 is 23 less than 4 times this number, right? So if I take 4 times this number, and I subtract that 23, is that going to equal 97? Yes, it is, right? 120 minus 23 equals 97. The grain elevator weighed Mr. Young's truck at 17,760 pounds before he dumped his wheat. The weight of the empty truck is 6,180 pounds. If the wheat weighed 60 pounds, how many bushels of wheat did he deliver to the elevator? And it's pounds per bushel here. All right. So you have a lot of stuff going on. You want to first figure out what you're looking for. All right. What you're looking for. How many bushels of wheat? That is what we're looking for, right? And so we need to assign a variable. They actually use the variable b. You can, but sometimes that will look like a number. So I would probably just use an x here and just say that it is bushels of wheat. Okay. I don't like to use anything that might be misconstrued as a number. And sometimes b will look like a 6 if you're not careful. All right, depending on how you write your b's and how quickly you write them. So be careful when you choose your variables that you don't choose something that looks like potentially a number, all right? Or like t's, sometimes people write them too quickly and they look like a plus sign. So you want to be really careful when you're choosing your variables. All right, so it weighed a certain amount before he dumped his wheat, all right? The weight of the truck is 6,180 pounds and wheat weighs 60 pounds per bushel. So when you see this little slash, that means per. So if I had like $3 per gallon and I bought 6 gallons, how much did I spend? If it was $3 per gallon. Yeah, so you multiplied. So anytime you see the word per or that slash indicating that's what it is a multiplication, all right? So if each bushel of wheat is 60 pounds, and I don't know how many pounds he has, right? I don't know how many bushels he has. I have to multiply the 60 by that variable. So if I take 60 and I multiply it by how many bushels I have, I will have the weight of the wheat. Everybody agree with that? If it's 60 pounds per bushel and I multiply it by the number of bushels I have, then that will be the weight of the wheat. If I add the weight of the wheat, so this is how much this weighs. If I add that to the weight of the truck, I should have the total weight, right? So what was the weight of the truck?
17,760 pounds.
The empty truck. Yeah, so you've given me the total. So what's the empty truck?
6,100.
Right, so that is the empty truck. That's what I should have said. And when you add those together, yes, you get the total weight of the truck and the wheat, which is what?
17,760.
All right. So they want to know how many bushels. This is the only way to find it out. The weight of the wheat plus the weight of the empty truck is going to be the weight of the truck and the wheat. We know the wheat is 60 pounds per bushel. So 60 times the number of bushels will tell us how many bushels he has. All right. So we're going to solve this one. All right, so we're going to subtract our 6180 over. Yep, so we're going to just subtract this over. And you can do your subtraction here, right? We're going to have to borrow here. 0 goes down. 16 minus 8 gives us an 8. 6 minus 1 gives us a 5. 17 minus 6 gives us an 11, right? What's my last step here? Divide by what?
60.
Divide by 60. All right. Now, just a quick note. When you're dividing like this and they both have zeros, you can cancel 0 for 0. So you can say 0 here, 0 here, right? And then you can just divide. 6 goes into 11 one time with 5 left over. 6 goes into 55 9 times with 1 left over. And 6 goes into 18 3 times. We have 193 bushels. All right. Through it. The first one says the difference, it's a key word, of a number. We do not know the number. And 72 is, that's another key word, 12. So the difference of a number and 72 is 12. We're going to set that up and then we're going to solve. Add 72 to both sides. Remember, when you go across the equal sign, you always want to do the opposite. All right. The next one, Kent has 3 times as many stamps in his collection as Jen has in hers. If Kent has 243 stamps, how many stamps does Jen have? What do we not know? That's what we're actually going to have our variable here. Our variable is going to represent the number of stamps that Jen has. All right, her stamps there. Now it says that he has 3 times as many stamps as she has. How would we write that algebraically?
3x.
3x. And if we take the number of stamps she has and we multiply it by 3, we get the number of stamps he has, which is what? 243, which is how we should have set this up. And then we are going to solve by division. So you will get 81, which means she has 81 stamps. All right.